Hello, my name is Rafid Fawwaz. I'm from Group 3. My name number is 1806-187682. I will present you from 3.3 until 3.5.
Guys, I'm Rafi from Mechanical Engineers, and I would like to address you about Chapter 12 in Calculus 2. It's basically about the derivatives of a chain link of two variables. That's my cat, I'm so sorry.
Hello, my name is Nathania Hillary and I'm going to explain about maxima and minima.
Hello everyone, I'm Yasmin Washyla from Metallurgy and Material Engineering. In this video, I'm going to tell you about partial derivative and a function with two or more variables. So, we're going to talk about the function of several variables. A function of several variables is a rule that assigns a real number fxy to each pair of real numbers xy in the domain of the function. We write the formula as this. For example, fxy is squared cos y. But note that the definition easily expands to three or more variables. For example, fxyz equals to x squared cos y sin z. And the domains is, unless specifically stated otherwise, the domain of a function of several variables is the set of all values of the variable for which the given expression is defined as example, this formula. We cannot have x equal to 2 and we need 3x more than 3 and need y equal to or more than 2. And the formula is stated here.
3.3 Limits and the continuity. Limit. A limit is a number that a function approaches as the independent variable of the function approach as given value. As you can see the example of the limit. Continuity. Continuity is another far-reaching concept in calculus. Existence of limits. Limit fx, x approach a, fx exists if limit fx, x approach a minus and limit fx, x approach a plus. And this is the example of existence of limit. Continuity. Fx define limit fx exists limit x approach a fx equal to limit x approach a fx. And then this is the example of continuity. X squared plus 1, x less than 2, and x plus 3, x more than 2.
5. Differential. Differentiation of a function. Differentiation is an explicit form of a derivative. And if a derivative of function fx is equals to f derivative x. And we define the differential as fx equals to dfx, where d means derivative. What is dx? dx is the differential element. And here is the example. Yada yada yada. Y squared is equals to x squared plus c, where c is 2 smaller c. And 3.5 is the directional derivative and gradient. This is the definition of directional derivative. Fz is equals to fxy. And then the direction is a vector. And this is the definition of the gradient, or in Indonesia is kemiringan. Kemiringan suatu plane. And here's the example for both. For the example of 1, at the point 3.2 and the direction of 2.1, the solution is as above. And this is the 3.6 for chain rule. What is chain rule? Basically, we have to differentiate the outer and the inner part of a function. This is the chain rule says fgx, and gx. We have two derivative both of the function. But first of all, we have to find the inner part and the outer part itself first to find the result. And for the last is tangent plane and linear approximation. What is a tangent plane? Tangent plane is where a shaped object meets barely or kiss with a graph. Here is the example of the plane itself. As you can see, the circle plane is approaching or barely meeting the graph of xyz. In the picture is an arrow. And this is the formula and the question that we sometimes see. And after that, we can see the graph of the formula and the result. And let's go straight to the linear approximation. What is linear approximation? So basically, linear approximation is a method to approximate to a value at a certain point. Because we cannot find, or we can though, but it's pretty difficult to find a value at a certain point. So we have to use an approximation to make it easier. This is the type of question that we can see. Fx is equal to root x. And fx, we can derivative, f derivative x, we can see that at the point 9.3, that's the result. Since the 9.3 is pretty same at tangent lines with the point of x equals 10, we can use approximation of root x equals to 10. That's it.
We are going to learn about minima and maxima. A maximum is a high point and a minimum is a low point. In a smoothly changing function, a maximum or minimum is always where the function flattens out, where the slope is 0. The derivative will tell us Let's dive right with an example. A ball is thrown in the air. Its height at any time t is given by. What is its maximum height? The answer is, using derivative, we can find the slope of that function. The slope is 0 at time 1.4 seconds. And the height at that time is 12.8 meters. And this is the graphic. How do we know it's a maximum or minimum? We saw it on the graph, but otherwise, the derivative can come to the rescue again. Take the derivative of the slope. When a function slope second derivative at x is less than 0, it's a local maximum. When greater than 0, it's a local minimum. We are going to learn about the method of Lagrange multipliers. In a mathematical optimization, the method of Lagrange multiplier is a strategy for finding the local maxima and minima of a function subject to equality constraints. And here's the example. The answer is, from the first equation, we immediately have that 4x equals to and we get the point is 3/10, and this is the graphic.